This right here is problem number 2 from the 2003 Amy 2. So let n be the greatest integer multiple of 8. No two of whose digits are the same. No two of whose digits are the same. What is the remainder when n is divided by 1,000? So let's think about it. No two digits are the same. Well, we only have 10 digits, 0 through 9. So this, if no two digits are the same, we can only have 10 digits in the number. So let me draw 10 spaces here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, we want it to be the greatest integer multiple. We want it to be the greatest integer multiple of 8. So we want this to be as large of a number as possible. So let me put it here. So this is our n. N is going to be this. We want it to be as large as possible. So if we want it as large as possible, we want the largest possible digits in the largest possible place. And we want the smallest possible digits in the smallest possible place. So let's just try out some numbers, not even thinking about whether they're divisible by 8. And then maybe we can rearrange what happens near the end of the number to make it divisible by 8. Because 1,000 is divisible by 8. So really just what happens in the last 3 digits is really what matters in terms of making it divisible by 8. So the largest number that has all unique digits is 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This is the largest possible number with unique digits. Now, what we care about is whether it's divisible by 8. So we really just have to look at this, because we know that 1,000 is divisible by 8. 1,000 divided by 8 is 125. So what really matters is all the stuff after 1,000, or the hundreds, tens, and ones place, whether this number right here is divisible by 8. Now we look at 210, just the way I wrote it right here. 210 isn't divisible by 8. 200 divided by 8 is 25, and then you have 10 left over. This is not going to be divisible by 8. This is going to be 26 with a little bit of a remainder of 2 or something like that. So maybe we can rearrange these numbers so it is divisible by 8. If it isn't, if we rearrange these and we can't get it divisible by 8, then we might have to borrow some numbers out here. But we don't want to do that, because we want the smallest possible numbers over here so that the large numbers can make this number super huge. So let's try to do this. So this one does not work right over there. Let's see, if we rearrange the 1 and the 2, we would have 1, 2, 0. This is divisible by 8. 8 goes into this. Let's see, 8 times 5 is 40. So this is going to be 8 times 15. So this works. This is divisible by 8. So if we make our entire number, 9, 8, 7, 6, 5, 4, 3, 1, 2, 0. We are divisible by 8. And they want to know the remainder when n is divided by 1,000. So when n is divided by 1,000, the remainder is just going to be anything smaller than the thousands place. So the remainder is going to be 120. And we're done.